to day 5 of our review. Today I want to talk about another very important topic, absolute max and absolute min. Whenever we want to find either an absolute max or an absolute min, we need to consider the extreme value theorem, the EVT. Okay, that stands for, again, extreme value theorem. Extreme values are maximum values or minimum values on an interval. And we talk about it being the absolute max to differentiate it from a relative or local max. Local max just means in its own little area, it's the highest. Absolute max means it's the maximum value on the interval. Here's what we know. As long as a function is continuous, f must be continuous. So if f is continuous, it will have an absolute max or min. Okay? An absolute max and absolute min they can only occur at two types of points. They can only occur at endpoints or critical points. So, if we have a function f of x, and we know f of x is continuous, okay? Let's say it's continuous on a, b. And I want to find the absolute max and absolute min. What we need to do is we need to check the endpoints a and b, and we need to check any critical points. So what I usually do first is I figure out the critical points by setting f prime equal to 0. Let's say f prime of x equals 0 at points x equals c and x equals d. First thing I need to do is check, are these 2 points in between a and b, right? So let's say a is 0 and b is 10. If c is 5, I can use c. But if d was 11, I can't use it, okay? But let's say, for purpose, let's pretend both of them are between a and b. Then what we do is we make a little chart to test with x values and then f of x values, right? And we need to test our endpoints a and d. But we also need to check A and B. We need to check, C and D as well. So we need to check all of the critical points and endpoints, and we plug them into the function f of x, right? And when we plug those in, right, we'll get various answers here. Let's say we plug them in, we get 10, -5, -1, and 16. Well, then 16 is our absolute max value, and -5 would be our absolute minimum value. Okay. So that over that interval, that was our minimum value was -5, our maximum value was 16. Sometimes they use the word absolute. Sometimes they just say, what is the maximum value of the function? Okay. But this can be kind of tricky depending on how difficult the function is to work with. Today we worked on a rate in, rate out problem in class. I want to do an example of that here. So here's the problem. A tank is filling with water at a rate of R of t equals, well, I put it on my calculator, 10 minus 2e to the negative cosine of 2x, or sorry, 2t. In liters per minute. Okay. The tank is leaking, and it's filling at that rate in liters per minute from 0 is less than or equal to t is less than or equal to 5. Okay. And let's say d of t equals 0.5x squared plus 1 is the rate the tank is draining. Again, in liters per minute. From 0 is less than or equal to t is less than or equal to 5. Okay. At t equals 0, the tank contains 30 liters of water. Okay, there's our setup. So this is your classic rate in, rate out. I'm just going to annotate with what the rate in, rate out things mean. This R of t, since it's the tank filling with water, this is our rate in. D of t is what the tank is draining, so that would be our rate out. And this is our initial condition. It's really important to keep all of those things straight. The type of question they might ask here is, I'm going to ask both questions here. What is the maximum and minimum amount of water in the tank? So the question is, what is the maximum and minimum amount of water in the tank? On the interval 0 is less than or equal to t is less than or equal to 5. Okay. So that's our question. We want to know, what is the maximum amount of water in this tank? What is the minimum amount of water in the tank on the interval 0 to 5? Well, the first thing we need to think about here is, okay, they want the absolute max and the absolute min. What I need to do is come up with an equation for the amount of water in the tank, and I need to check the endpoints. So I need to check 0 and 5, but I also need to check any critical points as well to figure this thing out. So here's what I'm going to do. I'm going to write an equation that's going to give the amount of water in the tank at time t. So here's what I have. Well, the amount of water at any time t will be our initial condition first. So I'm going to say 30 plus the integral. The other thing to pay attention to here, both of these rate in, rate out, they go from 0 all the way to 5. So we don't have to change the lower limit of integration. So it's going to be the integral from 0 to t of r of t dt. It's going to be the initial condition plus the integral of the rate in minus the integral of the rate out. Okay. That is my formula. Right away I know right away in my table here, in my test chart, I need to check 0 and I need to check 5. I must check the 2 endpoints. So I also need to check any critical points. Well, by definition, a critical point is the derivative of the function when that derivative of the function equals 0. I need to figure out when does a prime equal 0. Well, a prime would be, well, the derivative of 30 is 0. Fundamental theorem of calculus says the derivative of the integral from 0 to t of r of t dt will simply be r of t. And this derivative will be d of t. Okay? So I set r of t minus d of t equal to 0. Well, to solve this, all I'm going to do is add d of t to the other side. And I'm looking for when r of t equals d of t. That's what I need to figure out. And then I need to plug all of these into my equations to solve. Okay? So let's use our calculator to help us here. I'm going to go back to my calculator here, and I'm going to type these functions in. I'm going to do this carefully. If I make a mistake here, it's going to hurt. So let's type these in as carefully as possible. It's 10 minus 2 e to the negative cosine of 2x. Okay, double check, that looks good. My other one is 0.5t squared or 0.5x squared plus 1. Okay. That's my rate in and my rate out. I know my window should be from 0 to 5 on the x. And so I'll do 0 to 5 here. And maybe I'll do 0 to 20 here. Okay, the first one I typed in was my rate in. So when I hit graph here, it's going to show my rate in first. There's my rate in. And there's my rate out. So I need to determine where my rate in equals my rate out. Well, what we're looking for is this place right here. See where my cursor is? Where those two lines intersect will be our critical point. It'll be when r of t equals d of t. So I'm just going to go second trace to use my calculus. I'm going to find the intersection. I'm going to arrow over here. And hit enter. I'm going to hit enter, and I'm going to enter one more time. And I need to write down all of these digits. So again, my intersection is at t equals 3.8322895. Right away, I want to store that intersection on my calculator. I've been using A a lot, so I'll use the letter C. I'm going to hit second quit, and I'm going to store. I'm going to do answer store as the letter C. You can use whatever letter you want. I'm going to store that on my calculator, but I also need to write that in the scoring region. So going back here, I'm going to write r of t equals d of t when t equals, I got to write down all the digits, 3.8322895. And I chose that to be letter C. That was my only critical point. The only intersection on the window 0 to 5 occurred at point C. Just make sure if you're going to use letters, you need to have this code for your graders here so they know where you're getting that from. Okay? Now, I must calculate A of 0, A of C, and A of 5. All three of them are possibilities for my minimum value and my maximum value. A of 0, we should see very simply, is just our initial condition, right? If I put both of these to 0, an integral from a number to itself is always 0. So it's 30 plus 0 minus 0. I get 30 right here. But to figure out, so A of 0 equals 30. A of C would be 30 plus the integral from 0 to C of r of t dt minus the integral from 0 to c of d of t dt. So I'll go to my calculator and figure that out. So I'm going to do 30 plus math 9 integral 0 to c. And again, c only works if you store c in your calculator. Of my rate n, which was alpha trace y1 dx minus math 9 for my integral 0 to c of my rate out, which was alpha trace y2. And I get 46.455. Okay. But again, I don't know my maximum or my minimum yet until I check at 5. So I also need to check what A of 5 equals. Well, it's going to be the same formula that I used for A of C, but all the C's are going to switch to 5. To make this easy, I just go up and highlight my entry. I'm just going to arrow back, and I'm going to write 5 over C. In both places, and I'll hit enter. And I get 40.752. Since the question asked for the maximum and the minimum value for the amount of water in the tank, I can now just look and say the maximum value of water in tank is 46.455 liters. The minimum amount of water would be what, 30? Yeah. This is my max. This is my minimum. So the minimum occurred at the initial condition is 30 liters. Okay. So that's how we do absolute maximum values and absolute minimum values. By the way, whenever they ask for the max value, you always report the y. If they said, at what time does the max value occur, we would say the max value occurs at time t equals c. Or then we could report it as 3.832. Okay. Notice that t equals 3.8322895. Because that wasn't my final answer, I wanted to write down all of the digits. I don't round or truncate until my final answer. All right, that's it for today. And I'll see you for multiple choice Monday. Have a great weekend. Talk to you guys later. 2 chains. Bye.